Hello, Mr. Bain here. Today's lesson is 2.5, creating and solving compound inequalities. The essential question is how can you solve a compound inequality and graph the solution set? And the standard A.CED1, create equations and inequalities in one variable and use them to solve problems. So, the first thing that we need to think about here is what is a compound inequality? Well, we have a definition of a compound statement, and that is it is a statement that's formed by combining two or more simple statements. And by statement, we mean things like inequalities or equations. So if you look at this table below here, this is going to be important in how we combine our statements. So if we have something like a dog is a mammal, then red is a color. Okay, so we want to think about whether or not we can put those together using the word or. And I'm actually not going to do this as an example. I'm not going to go through it. But think about combining those, and if it's true or false, using the word or, then using the word and. I figured let's go directly to the math here. And part C. So we have 1 is an odd number, 2 is an even number. So when you look at is 1 an odd number, is that true? So it is, it's true. And 2 is an even number, that is also true. Then let's go ahead and look at the rest of these. 1 is an odd number, P is, that's true. 2 is an odd number, that's false. So let's shorten this up a little bit. True, then false. The third one, 1 is an even number, that's false. 2 is an even number, that's true. And then the last one, 1 is an even number. Nope. And 2 is an odd number, also false. So the third column over here is asking P or Q. So I'm going to say the P statement, then I'm going to say or, then I'm going to say the Q statement. That's how we combined or create these compound statements. So the first one is 1 is an odd number or 2 is an even number. So is it true that 1 is an odd number or 2 is an even number? And yes, that is true. And I'll let you kind of think about the rest of them, but I'll tell you that the second one's true, the third one is true, and the last one is false. So try to think about which ones are true, which ones are false, based on these two columns right here. Okay? And you can think about that, maybe even write what you think here in part D, P or Q is true when what happens. On page 82, you're going to get a definition of a compound inequality and also how we use the word and. So this is we're gonna kind of tackle each of these compound words separately. The word and, which is going to lead to something that we call the intersection. And the word and is used in these different ways using words, algebra, or graph. Kind of be familiar with all of them. So read through that as reference, but we're going to go straight to an example on the next page. So look at number 3. You'll see this where it says -2 is less than, x minus 3 is less than 5. So this looks different. We have two inequality symbols in here. We no longer have just the left side and the right side. We've got like 3 different parts here. So think of that as first part, second, and third. So one way that we could solve this is if we want to get x by itself, think about what's with it. We have a minus 3. So I want to add 3 to get that x by itself, which means to the other 2 parts, I'm also going to add 3 to them. So this is kind of weird, kind of different, where I'm not using a property of equality, like not adding and subtracting things to the left and to the right side. I'm doing it to 3 different sides. But if you do this correctly, you'll get 1 is less than x is less than 8. Okay, let me show you how it would look if we actually split it up, because there's another way to write this, and see if you can catch on to how I'm doing this. So I'm going to go back to the first original sentence here, and negative 2 is less than x minus 3. I just took the first two parts of that compound inequality. Then I'm going to put the word and in between, because this is important. And I'm going to take the last two parts of this. The last two parts says x minus 3 is less than 5. Okay, so I need to find out the solution where negative 2 is less than x minus 3 and x minus 3 is less than 5. So if I solve each of these, hopefully you can solve, should be able to solve each of these two inequalities. Then I'm going to get 1 is less than x, and for the second one, add 3 again to both sides, and x is less than 8. So here we go. Here is a solution that you could have, and this is also a solution. Ultimately, I don't really care with which one you get because they mean the same thing as each other, but you do want to be familiar with both because you could be given a compound inequality in both ways. Let's graph it though. So the first part, 1 is less than x, means that x is bigger than 1. So at 1, open circle. X is bigger than 1 means it's going to be going this way to the right. Right? So that means 2, 3, 4, 5, 6, and so on. Then the second part, x is less than 8 means I've got this open circle at 8. It's going to be everything smaller than 8, which is going that way. So using the word and means I want numbers that do both. It's greater than 1 and less than 8. So think about this. Is 9 bigger than 1 and less than 8? It's not. 9 is only bigger than 1, but it's not also less than 8. We want it, remember, we want it to be both. So if you think about this very carefully, it's going to be everything in between 1 and 8. If I take any of those numbers, decimals, fractions, whole numbers, whatever, everything in between 1 and 8 is going to satisfy this compound inequality. So make sure you're shading in between the 1 and the 8. You could erase these arrows that I've drawn, erase those so that you don't get confused. And I don't get confused if I'm looking at your solution. I'd like you to try number 4 on your own before you see the solution. Okay, so if I'm going to write this out, I could write it as negative 10 is less than 3x plus 2. And if I take the last two parts of the inequality, 3x plus 2 is less than or equal to 8. So I'm going to solve it both ways, just so you can see the work being done here. I'm going to divide all of these different parts by 3 at the end to get my solution. And then I'm going to also solve it using the word and. I'm always underlining the word and because it is so important that you have that word there. If not, I'm not sure how these statements are being combined. So again, make sure you have that word and then pretty soon we're going to be dealing with the word or when we're combining these inequalities. Okay. Now that we have our solution, let's go ahead and graph it. X is greater than negative 4. So open circle going to the right. And x is less than or equal to negative 2. Notice I have a closed circle there. Less than means I'm going to the right. Because I'm using the word and, I need it to satisfy both inequalities at the same time. So it's going to be everything between negative 4 and 2. It's also going to include 2, because think about this. 2 is bigger than negative 4, but it's also less than or equal to 2. And there is the work using the word and. Let's move to the word or. Here are some reference problems down below. Right here, read through that if you need to. The right above the table talks about what the word or does in a compound inequality, and that we're going to do this thing called a union. Think about what union means in regular English. Like we're going to combine things together. So we're not looking at an intersection. All we're doing is we're taking the solution of one inequality and we're just going to combine it with the solution of the other one. Page 85, let's look at the your turn. Go ahead and pause this at any time if you want to give these a try. The different thing here compared to using the word and is that these cannot be written any other way. You have to use the word or just because we're combining the solutions of these two different ones. So number 6, I'm going to add 5 to both sides and I get x is greater than or equal to 3, or x is going to be less than or equal to -1. That's when I add 5 to both sides. So let's go ahead and graph this. X is greater than or equal to 3, which means closed circle at 3 going to the right. Yeah, greater than or equal to. Or x is less than or equal to -1, closed circle, -1 going to the left. So now think about, I'm going to combine all solutions. Okay, you need to think about this for a sec. If I said I want the numbers x that are bigger than or equal to 3, or I want the values of x to be less than or equal to -1. Okay, think about even this symbol right here. This means less than or equal to. That means I want it to be one of them. Now in this case, it can be both, but there's no number that satisfies both anyway. So let's say I just chose, I don't know, the value -4. Okay, right over here. Is -4 greater than or equal to 3 or less than or equal to -1? And the answer is yes, it is. It's this one, right? -4 is less than or equal to -1. Therefore, this whole compound inequality is true when x equals -4. Okay. If I'm thinking of like the value 0, right? Is 0 greater than or equal to 3 or less than or equal to -1? And the answer is that's false. It's neither one, right? So it's false. So 0 is not a solution in that case. Okay, the very last problem here, number 7. Let's just go through and solve it. Add 1 to both sides. We get that. And so x is less than 4. Or, when we solve the other one, divide both sides by 8, and x is greater than or equal to 6. So at 4, x is less than 4. So that's how I graph that. And x is greater than or equal to 6. And that's how we graph it. And I don't do anything else. There's no shading that needs to happen. Just think about this. I have all my solutions to this whole compound inequality here is every number that's 6 or greater, right? So all of those are solutions to the whole compound inequality. The solutions that are less than 4 are, the values that are less than 4 are also solutions to my compound inequality, right? So we're taking the solution of one inequality and combining it with the solution of the other, and all of those altogether are each a solution to the whole compound inequality. And the last type of problem is to look at graphs and be able to create a compound inequality from there. So let's try a problem. It's number 9, number 10. So the first thing is if we look at one endpoint here, we're at -8, and then the other one is at -3. And so think about which direction it's going. So if I look at -8, we're looking at the numbers that are bigger than, okay, this shaded part right here. So x is going to be greater than -8. X is also going to be less than -3. Right? So no closed circle, so I'm just using the greater than the less than. Because I'm looking at an intersection that's in between both of them, we're going to be using the word and that's it. Okay, try number 10. Try it out before you see the solution. So we're going to have x is less than -4 for that part. Then we're going to have x is greater than or equal to 2 on the right side. And it looks like they're combining these solutions together. They don't intersect in any way. So that means we're going to be using the word or to create our compound inequality. And that does it for this lesson 2.5. Thank you so much for watching. Have a good day.